Hello everybody. Today I'm going to show you how to install a library or a software package called VQGAN-CLIP. What VQGAN-CLIP is, it's an open source Python library which uses an ImageNet transformer to minimize a loss between a textual prompt and an output image, and this renders an AI image essentially. I have a few examples here of arts that can be generated in this style. So obviously some of these scenes can be riveting. This one, kind of. I have a few others. It's interesting because I can just have the machine mind choose, or the AI, the machine mind represent kind of like a cultural array representation of this, because an ImageNet transformer is built on many hours of handcrafted data and labeled specific, like this is a cat, this is a bird, were early examples of that, and now they're packaged into these kind of monolithic architectures known as transformers. And the transformer then goes into the architecture and is able to turn these word prompts into images based on long representations of these textual prompts. So these are a few examples of things that I've been working on in my time. I kind of like this one. It was my supper. I made this one for supper. It was a photo of my supper that I then described as delicious Asian noodles because I had used the various sauces. So if you're interested in making images like these, I'm going to show you how to install those now. Alright, so the first step is that you come over here to the Miniconda Anaconda documentation. You can look for, on your distribution, just search for Conda installer. I use the Anaconda installer for Linux because I currently run a Linux Mint setup. I click this link. It takes me over to here where I can click the download button. You don't have to enter your information, you can just close out of that. I'm going to cancel this one because I already have it downloaded. We go back here, you open a terminal where now you activate that command that it's showing. I have this in the downloads directory, so I run the bash command on the file which is located in the downloads directory. Enter the prompts as needed. I'm just going to enter through all this, read the agreement, just in case. Enter yes. Confirm location. It installs in its own directory inside of the home directory where I already have it installed. So that's all good. We can move on to the next part. For you, it might take time. But you'll get confirmation that it is good when you're done. Alright, next step is to get the Git repository, the open source repository, which is hosted by Nerdy Rodent at VQGAN-CLIP. And they conveniently provide us with a README file which shows some of the original artwork by the author, as well as a setup. So once again, I'm going to open my terminal here. And since I have run the Anaconda installer, I have access to that package. I can now go Conda, create, name, VQGAN, Python, and use the latest version, which I believe is still 3.9. I have an existing directory, so I'm not going to go forward with that, but it'll install automatically once you do. Next thing you need to do is activate that directory. So I type Conda activate VQGAN, and then I'm going to copy straight from the README file here into the shell, where it will now download some of the repositories. This is for CUDA versions of PyTorch. You're installing PyTorch, which is the, if I remember right, it's a machine learning library that's commonly used. It's a commonly used machine learning library. It's not TensorFlow, it's PyTorch. It has its own, I think CV2 or OpenCV, one of the two is based on the PyTorch framework. Once that's installed, we select this next line where we install additional Python packages. These include things like regex is for searching lines, textual inputs. I'm not sure about ftfy. TQDM, I believe, is derived from the Arabic term for duration or waiting, and it sets timers and that kind of thing. OmegaConf, I'm unfamiliar with. PyTorch lighting would be a PyTorch derivative. You know, these are packages that are going to be useful and used commonly. So I just copy those. Excuse me while I clean that up. And I use the pip package manager to install them. And again, because I am in my VQGAN environment, which we can see here, these packages are being installed within the VQGAN environment. So if you ever run into an issue, which I have several times, trying to generate images with this tool set, and then you run into a broken pipe error, it's likely because you haven't changed into the proper environment and the program is unable to access the appropriate libraries. So after I've installed that, I clone the repository. I have that so I can clone or git clone this GitHub part of it here into the HTML. I host my version of the software in my opt directory since I use Linux, and I felt it was an appropriate place because it's not a total package itself. It's a third-party software. If it were a third party, it would belong in the etc folder, but I didn't use that. So I've run into one issue here. I'm going to try rerunning that. And it looks like it's going to go this time. It was unable to resolve the host for some unknown reason. It could have been inside of the package manager, or sorry, not the package manager. It's like a routing problem, something in the IP authority. So now, if I show my working directory right here with the ls command, I see that I have VQGAN-CLIP right here. So what I do now is I change into that with the cd command, and now I clone clip, which is another repository, another open source library from OpenAI. It's hosted by OpenAI, and Nerdy Rodent obviously use this quite extensively in developing VQGAN-CLIP. I believe what CLIP does is it embeds the vector identity of the prompts. From what I've dug into that, it's the one that vectorizes the text, and then you're now able to create this loss function between the image transformer perceived output of it and then the input vector identity. And then we copy, once again, we clone another repository from Confviz called Taming Transformers. From what I'm familiar with, Taming Transformers, I'm actually not too familiar with Taming Transformers. I haven't dug into that side of this thing enough. I'll work on it more. So we see here we're receiving those objects. Let me stop recording. I'll get back once we're there. All right, we've finished cloning the Taming Transformers repository. I had a bit of time to read over this now, and essentially what it is a library for having access to the various pre-trained models. Because I'm not in the odds and ends of it, I just know that I have to use one of these data sets. I believe this VQGAN ImageNet is the one that I use because it's the standard when it's called in the VQGAN-CLIP library. But this is available on the README, the overview. You could also go to the GitHub itself, the Taming Transformers repository, and you can read about that in your own time if you'd like. So the next step we're doing here, and we're just following through on the README, is I create a directory with the makedir command called checkpoints. Now I'm going to curl, which means download from a URL, and I'm going to curl the ImageNet pre-trained model, and I'm curling it from a Heidelberg repository. And I believe the Germans are fairly well renowned for their proficiency in software and Unix systems. So that should come as no surprise that Heidelberg has something like that. So we can see here that both of these, the first one downloaded very quickly because it was the model.yaml, which I believe is just a configuration file. But the second one is going to take some time because it's quite large and it is the transformer itself. So I'm going to stop recording here again and get back to the video once that has installed. Alright, excellent. So we have a successful download of the Taming Transformers model itself. So with that, we can change into the, well, we're already in the VQGAN-CLIP directory. And what we see here is a file called generate.py. And that gives me, well, that starts taming the transformer. So I can run this as it is. And we see it takes a second. It creates this dimensional array, downloads the model. I'm familiar with this, so let me get back. Alright, so we have finished downloading that model, and when inside of this directory, if I use the ls command here, we can see that there's a variety or several commands that are listed. The checkpoints directory which are created, clip and taming transformers, which we cloned, but the prime interest is this generate.py file. So now if we go python generate.py, we see that it begins the neural network, the convolutional process, by restoring from that checkpoint which we had downloaded, creating an array of dimensional size, and then it begins iterating. The default is 500 iterations with the prompt acute smiling nerdy rodent. So this is, I like to think of it because why not, as like a little virtual hamster that now lives in a wheel that is the magnetic splatter disk that is spinning in my hard drive. But that creates, based on that prompt, there's additional commands which we can look at on this readme here. We can go through those. They're fairly straightforward. There's the image prompts and iterations which are, you know, useful. Display frequency, that's save every is the prompt. I set it at an even amount. Size, you'll find yourself limited if your GPU is not too great. I use a fairly old GPU, a 1080 GTX, and I'm able to produce images that are 304 by 304 pixels. With a more modern, like 3080 kind of setup, you'll have more success creating larger images. I've had some interesting results displaying the with initial noise. I haven't worked with many of these other ones. Learning rate is interesting if you've had a chance to read optimizer papers like the kind that created Atom or Atom W, RMS prop. You might have a little bit more intuition as to what a learning rate is. The output lets you select where to save that file, and zoom video or the video commands saves all of the iterations from the command into an MP4. You can select the video length of that as well as FPS and that kind of thing. A few things here. If I go back for a second to the README, I was on the README. No, let's just look at this. Just because I think it's useful to know a few of the kind of interpretations that come with the library. For instance, here, if I supply this prompt, or when the author of the library supplied the prompt, a painting of an apple in a fruit bowl, we can see the image that came out. Looks very much like a painting of an apple in a fruit bowl. So what's different? There's a new image here, right? What's different? Well, she supplied several prompts, which are all separated with a upward bracket to delineate them, and she was even able to give weight to the prompts surreal and weird equally by 0.5. So that's really useful if you find yourself caught and kind of wondering how is it that I can make kind of a cohesive story or pattern of structure. Just know that you can supply like one continuous prompt with this upward bracket separation. Image prompts are the same. We can see here on this other example by the author where she has supplied two initial prompts, one for Van Gogh and one for bedroom. But I don't believe that there's not a picture attached with that. which is okay because if you're interested, you can run it yourself. You have access to the software now. Story mode, if you separate your text prompts by this caret symbol where we see here, it creates kind of a story mode. So that might be another option that I will play with in the future. I've had a lot of fun learning these various things. Here they supply something called a style transfer by using the AtomW optimizer, low iteration count, and a fast learning rate, or like a high learning rate of 0.25. You don't want those too much because you wind up overfitting your data. Most times I use 0.1 as my learning rate. Because I think it gets back to like an explore-exploit contrast in the architecture or for the transformer. But here for this application where you see various styles output kind of the same image. So this is psychedelic, this is sketch, this is Picasso. They say that this low iteration rate with a high learning rate on the AtomW optimizer gives you that style transfer option. And here again from the artist directory, we see the zooming video effect. So if you want to call that, you would use the zvid command in your prompt. Over here I have, we see that the cute smiling nerdy rodent has generated. We have this image output.png, and if I can remember, which I almost never do, xdg open, we get output. XDG open, the output.png, and we have something that's faintly like a cute smiling nerding rodent. So thank you for sitting with me today while I showed you how to install the VQGAN-CLIP package, and I look forward to seeing some of the prompts and the visualizations that you're able to generate with this. Please leave it in a comment. I plan to create some other communications platforms in the future, and I'll be sure to be active on this channel as well. Thank you very much.